Hey guys, this is Devansh Kisrwani here and welcome to my channel Cses. Today we will solve the concert tickets problem from Cses problem set. So let's see the problem. The key points are we will be given with the number of tickets and the number of customers. Then the price of each ticket will be given, and then the customers will tell their maximum price in order they arrive. So each customer is going to announce the maximum price they are willing to pay for a ticket, and after this they will get a ticket to the nearest possible price. This line is important, to the nearest possible price, such that it does not exceed the maximum price. Let's understand with all this with an example. Here we have number of tickets as 5 and the number of customer 3. Then the next line is the price of each ticket. So these are the price of all the 5 tickets. And then this is the customer willing price. That means the first customer can afford maximum of amount 4 units of ticket. The second can afford up to 8 and the last one can afford up to 3. So what we need to do is we need to give the ticket to that customer to the nearest possible price. That means this first customer can afford up to 4. So I can give either, if the ticket price available 4 is there, I can give the ticket price 4. Otherwise, if it is not there, then I will give the nearest possible price. Then which is the nearest possible price in this? So 4 is not there, then the next nearest possible is 3. So we will give the first customer 3, price of 3 ticket. Now this second customer arrives, he can afford up to max unit of 8. So I can either give 8 or 7, 6, means the nearest possible price. So we'll see. I can give 5 also. 3 I can't give because this is given to first customer. I can give 7 also. I can give 8 also. So it is good if I give the 8th price ticket, right? 5, because if suppose I have given 5 and in future if some customer is willing to pay price amount of 6, so I can give that 5 to this customer, right? So that's why we'll first try to give the max possible to this customer. If it is not possible, then we are going to reduce. If suppose 8 was not there in this, then I will of course give 7 to this one. So now this second customer will get this ticket and it will be removed. So 8. Now there comes the third customer. He can afford up to max unit of 3. So 3 is there. 3 was there, but it has been given to the first customer, so it is no more available in the ticket list. So 3, no. So if the customer cannot get any ticket, we are going to print -1. So that's the problem. I hope it is clear. What we need to do, again I am summarizing it. We will be given with the list of tickets, then the customer will arrive one by one, and we need to give the maximum possible price to the ticket. If that max possible price is not there, so we will reduce the price and will try to give to that customer. Maximum possible price means that this first customer can give max 4. So we'll try to first give the 4 price ticket to him. If it is not available, then we will see for the next price. Okay, so let's try to revise the logic by taking an example of 5 and 3. 5 number of tickets we have and 3 as a customer, and this is the output. So you see 5, 3, 7, 8, 5. These are the prices, and the first customer announced its maximum price he can afford is 4. But 4 is not available. So what we are doing, we are checking, right? we check here, we then go here, we then go here. Instead of doing this process, we can sort this out. So we can sort this in ascending order: 3, 5, 5, 7, 8. Now 4, first customer announces price as 4. So 4. Now what we will do is, we will see, can we take this? Yeah, we can take this, but he can take this, but we need to check if 4 is available in further array, then that would be best possible to give that one, because why to waste the least one, right? Less price tickets. So we will go again and we'll check, but this has exceed this, so no matter what, we have to give the previous one only. So what we are doing is, we are going to the list, and in that list, we are using a loop to transfer this list, and in that we are again using a loop to find out the best possible element price. If I is this, and then j is finding the best possible price in this. So you see, we are using 2 loops, and with this this constraints 10 to the power 9, we will definitely get time limit exceed error. So even though the logic is working, but it is not under the time limit which they have mentioned. So we need to think of something else. We need to think something more. What we can do is, we are sorting and then we are searching. Which search we are performing? We are basically performing the linear search. So we have sorted, then we are performing the linear search. Instead of doing that, we can perform a binary search. And binary search works in log n time complexity. It's worst case. So the log n is going to satisfy this constraint. So we can build this log n time complexity logic, and we can use binary search for that. But why to reinvent the wheel when we have already this type of function available in C++ STL, which is called the lower bound. I have made a detailed video of this in my STL series playlist. You can check. I will provide the link in the description. But I will just here brief you out what this lower bound does is. So first of all, it works on the sorted array, either increasing or decreasing. So let's take lower bound when it is in increasing. The list is increasing. So let's take some random numbers. I'm just explaining what this lower bound does. 1, 2, 5, 8. So when the list is in increasing order and we perform a lower bound of any value, let's say 4. So the lower bound gives the value in the list equal to that value or greater than that value. So the 4 is not available in this list. So the next greater value, which is the next greater value in this? 5, right? So the output will be 5. So it gives the next greater value of the given value, the next greater value, or if that value is present, it gives that value when in case of increasing. And when in the case of decreasing, let's take this only. So this will be 3, 5, 5, 7, 8. In case of decreasing, if let's take 4, it gives either equal value or just a smaller. So if equal value is not there, it will give the just a smaller value. So which is the just a smaller value? 3. And 3 will be displayed. So when increasing, the lower bound gives equal or just the next higher value to that past value. And when decreasing, it gives equal or just the next smaller value. I think it is clear. and this performs. This is a function present in C++ STL, and it internally it performs binary search. So you see, if we do this decreasing one, then we are surely reaching the result, right? So again, we will perform the lower bound, and let's sort this in decreasing order, because we want the smaller value, right? Equal or smaller value. So 8, 7, 5, 5 and 3. So first 4 will perform the lower bound on this. So what it is going to be, it is going to be equal or just smaller. So just smaller is 3. And internally it is performing the binary search. And let's take 8. And when we have taken this 3, when we have passed the value 4, first customer 4, then 3 will be the output, and we will erase this off. Then 8 will come. Then lower bound equal or small, just a smaller in case of decreasing this. So equal is there, so we'll display this and remove this. Then the last customer, he announces his maximum as 3. Equal, if not there, it has been removed. Equal, and just a smaller value, it is not there. So the lower bound, it returns to the end iterator, and in that case, if the smaller value is not there, like in this case, no smaller value is there, 7, 5, 5, and it has to give value equal to 3 or smaller to that, but it is not there, so it will gives the end iterator, which we will see when we will code. So we will display -1. Like this we are going to build the logic, and we will write the program of this. Okay, so I am on my VS Code, and let's write the program of this now. So first input line contains an NM, and they contains the price, and the last contains the customers in order they arrive. And we can use int. So we'll say int n. This is the number of tickets, the number of customers. This m, and we'll get this cn. Now the next line contains the ticket, the price of the ticket. So we can use for loop for int I equal to 1, I is less than equal to n, I plus plus. So what we will input the price of the ticket. So we'll call it t, and let's make a vector here for price of ticket. So cin t, and we will push back this in our price of ticket vector. Now, as told, we will sort this, so we can use inbuilt function sort price of ticket dot begin price of ticket dot end, and we have to sort this in descending order, right? So we will pass here a function. So that function is, so yeah, greater int so now this has been sorted in decreasing order, and let's now the next line contains this, which is the customer. So we can check the customer line by line. So now first customer will arrive. So let's just in customer price, and I will input the customer price. Now what we need to do, we need to perform the lower bound. So how we perform the lower bound? We first create the iterator of it. If you have any problem in using lower bound, I have created a video of that. You can find the video in the description. I have talked detailed about how to use lower bound and upper bound. So yeah, so let's create an iterator for this. Now we can use the auto keyword, or we can create fully. Let's do the create in iterator, and iterator is equal to lower bound, and now here we will pass the range. So the range will be, we want in the full price of ticket vector, right? So we'll price of ticket dot begin, price of ticket dot end, and we'll pass the customer price in here, and we want it in work in descending order. So we'll pass this function also, and there should be semicolon here. I think this is done. Now as told, if the and yeah, now what we need to do, we need to display and also erase, right? We will display where the iterator is pointing, and will erase it off. So for doing that, and also if in this case, when the iterator doesn't find, what we need to do, we need to display not we display -1. So what we'll say, if the iterator reaches price of ticket dot end, means it hasn't found, so we will return cout -1 with a line break. And if it has found, then we need to perform two things. We need to dereference the iterator, and also we need to erase from the price of ticket dot erase. And I think let's try to submit this. Cosmetic. Okay, so there, okay, so there's a compilation error. It has to be double equals. And yeah, it gives time limit exceed error still. And why it is? We have used the lower bound function, and it performs binary search, and binary search do in log n time complexity, but it still this time limit exceed. And that is so because in case of vectors, this lower bound performs not in log n time complexity, but in of n time complexity. And that is why in some cases it is accepted, in some cases, like in port 1, it is giving time limit exceed error. because it is not working in log n time complex, it is working in O of n, and this is what I wanted to show you. So to handle this, we use sets, because if we are using sets, then in that case it performs not in O of n but in log n time complexity. So we will make some changes so that it performs it in log n time complexity. Okay, so let's do the changes here quickly. So we will use set, and but there is a problem lies, and that problem is, since it may contain duplicate element also, so we can't use just the set, we will use multi-set here, because multi-set holds the duplicate element also. So we are going to store it in multi-set, and if you have any issue in sets, I have that video also, you can check, you will get the link in the description. And the set by default store it in increasing order, but if we want to store it in decreasing order, and which is required in this case, we will use this greater int function here, and this is going to make sure that the price of ticket is stored in decreasing order, and we don't need this line now. And now we need the multi-set here, because it is going, now the iterator is going to point on this, it is going to hold this multi-set going to point in the multi-set, and we don't use lower bound like this in case of sets. We use price of tickets dot lower bound and also there is no pushback, it is insert here, and lower bound, and we just pass the customer price here, and that is pretty much, I think. We have made changes here. First we have made it in decreasing order, then we have used insert here, and then the iterator is going to point on the, so let's try to submit this. And it has been accepted. So you see, we learned here two things: how to use lower bound, a practical approach, then why there is a TLE in case of vectors, because it is not performing in log n time complexity, and when you use set maps, this performs in log n time complexity. Hope everything is clear.